Hey everybody, Tom Cherry Holmes here with the FujiNet project, and I wanted to do a video comparing and contrasting the R and the N devices. The R device is the combination of a virtual Atari 850 interface, which provides RS-232, and a Wi-Fi modem, integrated into one cohesive package, allowing for existing communications programs already existing for the Atari that use the Atari 850 interface to be used. The N device is actually a new device providing network card function, offloading a wide variety of protocols using the processing power of the ESP32, and as a consequence, exposing a clean I/O interface to the Atari and making it really easy to make whole new class of networking applications for the Atari 8-bit. But you may be asking, is there a lot of overlap between the R and the N devices? And yes, there actually is. But the way that they act, these two devices, act actually very different underneath. And this video actually shows to demonstrate some of the differences and how these two different devices, with totally different aims, but some overlap actually. To do this, I have my Atari 1200 XL, and I have an SID E3 cartridge plugged into the cartridge port with a SD card containing a hard disk image containing the FNC tools and a whole bunch of other things. Uh, my FujiNet's plugged into the back. It's turned on. It's currently in cold start mode. But because I actually have a partition set up here on drive A and that map is set to normal and the hard drive actually takes and overrides it. So when I do a directory on drive 1, you'll see that I get the contents of my hard drive image and not the ROM disk. You can actually use the map command to take into SIO to override, in which case you would get the FujiNet ROM disk. You'll see that I have an auto exec bat that basically sets a path for me. There's not much else to it, and my config sys, that's, basically quick add and make sure that SID E3 is set up and everything. But other than that, the standard Sparta-DOS X installation. If we go ahead and go into bterm here, which I have a copy of bobterm sitting over here, and we load the 850 interface handler. I'm loading the RHND 850 here because Sparta-DOS's rs232.com seems to have an issue with how the FujiNet loads its handler. You work around that just by not loading the handler off of Bootstrap, but just loading the handler. We'll take and load bterm using X here. And that's loading off of the SID. Bam, okay, great. And if we go set up a couple of things here, all right, and we'll see, thanks to the work that's been done on ticket number 371, that connecting to Atari BBS's works just fine. And right now we're using the SIO bus directly at a throttled speed of 2400 bits per second. And you'll see that what comes back is essentially a stream, a solid stream of characters. The bus is taking over everything, and it's running at 2400 bits per second. The data is coming back on the bus at 2400 bits per second. So you're seeing what is essentially a steady stream of characters at the baud rate that you choose. The FujiNet itself has a large buffer sitting on it, which ultimately allows for any network traffic coming in, which comes in as packets, to be buffered and siphoned off at leisure by the Atari. So we don't have to worry so much about what we historically have had to worry about with modem setups, with having to implement things like hardware-based flow control with RTS and C signals. All of that's kind of meaningless now. But you can see, I mean, in essence, when we're using bobterm, we're using a solid stream of data. It's basically this is how it's working, and you see the data's just across at a nice leisurely pace. The ESP32 isn't working very hard at all. It's already gotten all the data that's slowly coming across here, and the Atari is just slowly siphoning it off. And that's in essence what you're seeing here. Seeing this acting as a modem, streaming across as a modem. But this does have one very notable disadvantage. And that's that while this is happening, while this is acting as a modem, it has taken over the SIO bus entirely. You cannot use the disk drives, you cannot use a printer or any other peripheral while this is working without physically taking and overriding the bus. Now, what happens with the Atari 850, when the Atari 850 notices that the command line has been asserted, it immediately pops out of modem mode and starts to service the other peripherals on the bus. But while this is happening, especially with the original 850, you miss data that was coming across because there was no buffer for it. And it also had other weird issues. Basically, when this happened, your communications program had to be aware of this fact, and it would have to disable concurrent mode, which meant taking over the bus. It would have to hand the bus back to the Atari by closing the I/O channel, and then doing what it needed to do, and then reopening the I/O channel and putting it back into stream or concurrent mode again, potentially losing data in the process. Very awkward. The end device works very differently. We'll actually take and leave here so that happens. Out of here. And again, thanks to ticket number 371, this works beautifully. Leave here. We'll go ahead and queue to get back to DOS. We'll see that we're now setting back in DOS here. And let's go all the way back. Root. And we'll notice that we have right here, if we go into FNC, I've copied the FNC tools from my ROM disk over to here. And we have access to a whole bunch of different things, including the F tools. Look at FujiNet parameters like device slots, host slots. You'll notice that I don't have anything actually loaded into any device slots. Everything is running entirely off of my SIDE3 at the moment. That will change in just a second. But we can actually do other things, like say for we have access to the in command. One of those, I'm going to take and go. We'll now actually start to use the end device. We're going to use a command called ncd to change the path of the end device to a TNFS server to grab a file. And if we do an npwd, we see that it has changed. And if we actually do an end directory now, we'll see the top level of that TNFS file server. Cool, huh? Okay, so with that, let's actually go a bit further. Go into networking. Little caps lock there. And we'll see that we have a copy of netcat here. We can grab that copy of netcat and put it over. And we can take and now copy that file over. In fact, I'll delete my copy. You can tell I've done this before. Okay, so I now going to take a copy of netcat, call it nc.com, copy this over. Now, because ncopy actually uses the end device directly, it's talking SIO protocol directly over and bypassing CIO. This works under Sparta.x too. Uh, and because we're doing that, and because we don't have to deblock so much, it will transfer this file very quickly, especially since I'm over high speed. We see the file here, and if we do a directory, we can see it right there. Bam. Okay, great. So what is NC? NC is netcat. And netcat uses the end device directly to take and provide a simple input and output for the protocol that you use. In Bob term, we connected to the basement BBS using the R device as a modem. And here we're going to do the same thing with the end device. Now, this is very important because we're using the end device, two things are going to happen. One, we're going to be dealing in terms of packets directly. We're not streaming the data over at a leisurely pace. We're sending packets over as they are, as quickly as possible, using whatever speed your bus speed is. Because I have high-speed SIO turned on at 125 kilobits per second, this actually happens very quickly. We run NC inside Sparta.x. We see some basic commands here. We see a path a device spec that we need to provide, and optionally whether or not we want to turn on translation. There is also /E to turn on local echo if you need it for whatever reason. Add that into the go. So simple enough. But I need to take and do one small thing before we do that, because if we look and remember, NPWD is set, the end device is set to that path. That's going to cause problems for us. We just need to clear it. Once we clear it, bam, we're done. And look, now again at NPWD, it's clear, we're good to go. So now, if I run NC, we have to provide a device spec. And part of that device spec is protocol. And protocol could be something like TCP, it could be UDP, it could be TP, it could be S, it could be FTP, but doesn't matter. And in every single case, it's going to provide a consistent I/O channel that you can interact with. So, we'll use TCP since we are dealing with a raw connection to the basement BBS. No telnet processing needed. And we just simply do basement BBS, and it's on port 9000. That's all we need to basically provide. Since we're not doing any translation or any local echo, we don't need to provide any additional switches. And once it's actually open, provided nobody else is there, we're now sitting there. And the first thing you notice is that it's much faster. That's because we're not throttling to a baud rate. There. Ah, that's a nice little homage to optical race. Neat. Okay. So, you can see right here that the output is much, much faster. Because we're just dealing with the packets directly and getting them over as quickly as they can. This does mean that the ASCII animations do run a bit. But you can see that you can really see the marked difference and how this works and how this interacts. And if we take and do something like the solver to Zork 3, you can see that we're getting data over as quickly as we possibly can. You can see functionally much the same, but you have access to a lot of different things. But because you have this generic network interface, things get a lot more interesting. While you can, for example, use the R device to do telnet processing. There is a telnet protocol adapter in the N device as well. Yeah, excuse me. Little hiccup there. In the N device as well. So in telnet and local Raspberry Pi. You don't have to put the :23. If you don't, it defaults support 23, but I do want to take and put LF because I'm dealing with a Unix system here. And see, no echo. We're good to go. Bam. You can see right there, I quickly take, since I'm in at Spartados, and with one command, I'm instantly taking this. And suddenly, I'm sitting over here on my Unix system here, doing stuff. When I'm done, I just connect. We're back over here to Spartados X. Conversely, if for whatever reason I want to take a netcat something over, let me think for a moment while I figure out what to. Do I have anything over here that I can just display? Let's see if I do. Not really, but I guess I could take and let's say, for example, I'm gonna make a quick little world's quick. Pardon me. I'm gonna make a simple little ASCII text. Typing it out. Save that. And if I look here, for example, again, we'll see a little hello text file here. It's 51 bytes in length. Now, I could just as easily do this. Go ahead and set in do, for example, NC. And don't do any translation. We can, of course, okay. But what if I tell it to do some translation on the way in? Oop. Huh. Bug there. All right. Oh. Really? Okay. So that worked for. Okay, so there seems to be a bug with the file system. Okay. Yep. Fine then. Let's see what happens if it's 2. Ah. So as you can see, there's still some stuff. Big deal. Okay, I'm going to end this video here since I seem to have gone off the reservation. But hopefully, you guys kind of see sort of the differences and some of the power that's going to be available. Because NC itself is just a generic little funnel to the end device. It allows you to interact with the other side, and if there's any protocol offloading, it takes care of it for you. This happens on the FujiNet, and NC itself is actually a very small, simple program that you can see in the FujiNet apps repo. Very small. The R device is there specifically for existing programs. And the R device and the N device can both set up servers and listen for connection, but they handle them very differently. So the R device provides access to one connection at a time, just as a modem does. Whereas the N device can potentially listen to up to 4 simultaneous TCP connections, each of them on their own IOCB, or a multitude of UDP packets from multiple destinations. All up to you. I will take and expand on this further, but I felt it was kind of important to kind of show some of the differences because people are definitely confused as to how the N and the R device actually work together. And I'll end this. And until next time, guys, have fun.